All right, so guys, check this out. This is a 8.6 proportionality theorems. And before we get started with this kind of topic, we'll go back to 8.4 and 8.5 because you guys are probably asking why aren't we doing it or what's going on. So just a quick recap of what those two sections would have been. They would have been like, so 8.4 would have been angle theorem, and 8.5 is side, and side angle side. So they're proofs, okay? And they would have proven similarity. All right, and so again, just to recall, similar triangles, for example, would be if angle A is congruent to angle H, angle B is congruent to angle G, angle C is congruent to angle I. And then the side lengths right here are proportional. That means they have a scale factor. So 8.4 would have been like if angle A is congruent to angle H and angle B is congruent to angle G, then we can say the two triangles, so triangle ABC, I'll use the colors. So triangle ABC is similar to triangle HGI. Okay? And then for side, that would have been like if the ratio right here, so like let's go A over KA was the same throughout. They were equal to each other. This isn't ugly actually. If they're all equal to each other, so it's equal to B over KB, which is equal to C over KC, then we can say they're also similar. So they're just proofs. Side angle side would have been if this side right here, so like C and then KC, and then A is congruent to H is equal to, and the proportional, and A is proportional to KA, then that would have been side angle side. So they're just proofs. They can be kind of rough, especially if like they're rough as is, but it's way harder online. So we're not gonna do them, but that's just the gist of it. Okay.
All right, so guys, check this out. This is the triangle proportionality theorem, and it states if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So that just means like if TU is just some line that goes from this side to this side, and if it's parallel to QS, then the side, so RT over TQ, is going to be equal to RU over US. And the converse is just pretty much stating the other way. So if you have this line TU, and if you have the ratio, so like TR over TQ is equal to RU over US, then you can say this line, QS, is parallel to TU. So this pretty much just is just going to tell you if this line is parallel to this line. This one tells you that the ratios are going to be equal to each other. Okay, and that's all it is.
All right, so check it out. So in this example 1, we have this triangle, so triangle URT, and this line segment QS that cuts into it. And in this problem, they give us this information. So they tell us that QS, so this line segment, is parallel to UT, line segment UT. So just small note is this right here, this like symbol means parallel. Parallel lines are two lines that never touch. They stay equal distant the whole way through. So we know this line and this line are parallel because they tell us. Then they go on to tell us that RS equals 4. So RS is this segment right here is equal to 4. And then ST is equal to 6. And then QU, so QU is equal to 9. What is the length of RQ? So what we're trying to find is this length. So RQ would be from here to here. This is RQ. Now we're going to set this up using the triangle proportionality theorem, which states that RQ over QU, so this one right here, QU is equal to, and I'll use blue for the other one, RS over ST. So you can kind of see that. So the opposites of each other, so like Q and the 4, they're going to be on the same line. Okay? So RQ, RS, QU, and then ST. And then now let's put in the actual numbers. So I'll do like a little arrow. So we don't know QR, that's going to be the X, over QU, which is 9, is equal to RS, which is 4, over 6. Now, we solve this by cross multiplying. Some people call it a butterfly too. So just kind of keep that in mind. And it kind of looks like this. So, and I'll show you why they call it butterfly. So you're still multiplying, and then you make like, I don't know, something like, kind of looks like a butterfly. Yeah, butterfly. It's kind of pretty. Anyways, so x times 6 is 6x. 9 times 4 is 36. And then all we have to do is divide by 6. Divide by 6. And then we get x is equal to 6. We know x, we kind of like substituted, right? So we said x was equal to QR. So you do have to replace that. So Q, or RQ, right? RQ equals 6. All right, so example 2, they give us this information. And so the cool part about the proportionality theorem is we can also prove parallel or not. So we can prove if this line BD is parallel to this line AE. And we can do that by checking the proportions, okay? So as you can see, this is clearly this man right here, and he has the fresh kicks. These are shoes, and he is wondering if his shoe rack is parallel to the ground. So these are probably like Nike. Let me draw the swoosh right here so you guys can all tell. Swoosh. That way you all know. These are Nikes. You got the Yeezys over here, and this man is trying to figure out. So he's like dumbfounded. He's confused. How does he know if this line is parallel to this line? BD is parallel to AE. So he's going to go about this so they know. So we know that BA, so BA is 33 centimeters. We know CB is 27 centimeters. And then we know CD is 44 centimeters. I'm going to go on the inside a little bit. So 44. And DE is 25. So if this line BD is parallel to AE, then this should happen. So it should be 44 over 25, which is just this top part right here, and this part right here should be equal to, and then if we do 44 on top, that means 27 has to be on the bottom top, and then 33 has to be on the bottom. So so can we simplify this down? Is this simplifiable? So if I simplify, can I simplify 27 over 33? Yes. I can divide everything by 3, right? So this simplifies down to 9 over 11. And is that equal to 44 over 25? No, because I can't even simplify 44 over 25. So these are not equal to each other. Therefore, this line, BD, is not parallel to AE. That means this man's shoes are probably going to slide off. So not equal to, so not parallel. Now he's sad.
This is the triangle angle bisector theorem. And if it's pretty much just states if a ray bisects an angle of a triangle, so this ray, CD, bisects an angle. So that means that this angle right here, ACD, this part right here, is equal to DCB, this angle right here. If that were to happen, then this ratio, AD over DB, is equal to CA over CB.
All right, so this is example last, and we know the triangle angle bisector is this. So if we have this angle QPT, and if it's bisected by PQ, this line segment, this angle is going to be equal to this angle. With that being said, this ratio, so QR, this ratio, so from Q to R, over R to T, is going to be equal to PQ over PT. All right, so how are we going to set this up? Well, first of all, QR, we don't really know what that is, right? That's kind of a question mark. We know RT is this value, this X value. So it's going to be RT. Oh, and if you didn't know what this problem is asking you, you're solving for X, okay? Solve for X. Like most math problems, you solve for X. Anyways, solving for X, if we know this segment, RT, is 15, and we know this part is X, then we can do 15, this is like the entire part, minus X is going to be this little slither. So from here, and I'll use maybe even a different color. I'll use orange. So from here to here is going to be, I'll put my R on the inside, 15 minus X. So 15 minus X. Okay? And then it's going to be equal to, and now just to kind of keep it simple or like consistent, PQ is from here to here. So I'm going to change that to orange, 7. So 7 over PT, which is 13. All right. And now we kind of go about it. So now we're going to cross multiply that word again. So again, you're crossing and you're multiplying. So this is going to be, and I'll just go over here. So it's going to be 13 times 15 minus X. You have to multiply the entire quantity by 13 is equal to 7X. Okay, so now you have to distribute. 13 times 15 is going to be 195 minus 13X. And then that's equal to 7X. So we want to get everything to one side. So I'm going to plus this 13X over. Plus this 13X over. And when I say we want to get everything to one side, I want the variables to be one side and numbers to be on the other side. So I get 195 equals 20X. And then I divide by 20. Divide by 20. And then there's kind of a glare. but yeah, it's kind of stupid. Anyways, we have 195 over 20, and that's going to simplify down to 9.75 equals x. That's our x value. So this right here is going to equal 9.75. And then this, so if they did ask for like what's QR, that would be 15 minus 9.75, which is 0.25, so 5.25. So that would be from here to here. Okay, so that's it.